Dear friends, this video is chapter 2 of Basic Skill of Concrete Batching Plant. Useful to construction professional and technicians working in construction industry. We will discuss about A. Principles of concrete mixing and batching. B. Concrete batch plant operation, startup and shutdown procedures. C. Automation of concrete batching plant. We'll start presenting a new topic now. A. Principles of concrete mixing and batching. Concrete mixing and batching are crucial processes in the construction industry, ensuring that concrete is produced with the desired properties and consistency. The principles of concrete mixing and batching involve various factors and considerations to achieve high-quality concrete. Here are the key principles. 1. Proportioning of ingredients. 1a. Concrete is a mixture of cement, aggregates such as sand, gravel, or crushed stone, water, and sometimes additives or admixtures. The proportions of these ingredients must be carefully determined to achieve the desired strength, durability, workability, and other properties of the concrete. 1b. The ratio of cement to aggregates, known as the mix design, is critical and should be based on the project specifications and requirements. 2. Consistency and workability. 2a. The consistency of concrete refers to its ability to flow and be placed without excessive effort. It is often measured using the slump test. 2b. Workability is the ease with which concrete can be mixed, transported, and placed. Workability depends on factors like water-cement ratio, aggregate grading, and use of chemical admixtures. 3. Mixing process. 3a. Mixing should be thorough and uniform to ensure that all ingredients are evenly distributed. Inadequate mixing can lead to weak spots in the concrete. 3b. Common mixing methods include hand mixing, batch mixers, and continuous mixers like drum mixers or twin-shaft mixers. 4. Batching. 4a. Batching is the process of measuring and combining the ingredients in the correct proportions before mixing. 4b. Modern batching plants use computer-controlled systems to ensure accurate measurement and consistency. 4c. Batching equipment should be regularly calibrated to maintain accuracy. 5. Water-cement ratio. 5a. The water-cement ratio significantly affects the strength and durability of concrete. A lower water-cement ratio generally results in stronger concrete. 5b. Care should be taken to avoid adding excess water, which can weaken the concrete and reduce its durability. 6. Mixing time. 6a. The duration of mixing is crucial. Overmixing can lead to excessive air entrainment, while undermixing can result in poor uniformity. 6b. The ideal mixing time depends on the type of mixer and the mix design, but it is typically a few minutes. 7. Temperature control. 7a. Concrete temperature can impact the setting time and strength development. In hot weather, measures may be needed to prevent rapid evaporation and excessive heat. 7b. In cold weather, curing and protection from freezing are essential to avoid freezing and thawing damage. 8. Quality control. 8a. Quality control measures, such as regular testing of concrete properties, are essential to ensure that the final product meets the desired standards. 8b. Sample testing for slump, compressive strength, and other properties should be conducted regularly. 9. Admixtures. 9a. Chemical admixtures can be used to modify the properties of concrete. They may enhance workability, reduce water requirements, or improve durability, among other benefits. 10. Storage and transportation. 10a. Concrete should be transported to the construction site in a manner that minimizes segregation and maintains its properties. 10b. Adequate storage conditions are essential to prevent contamination and maintain the quality of concrete ingredients. In summary, the principles of concrete mixing and batching involve careful selection of materials, accurate proportioning, thorough mixing, and proper control of various factors to produce concrete that meets the desired specifications and performs well in its intended application. Quality control and adherence to best practices are essential for achieving durable and structurally sound concrete structures. B. Concrete batch plant operation, startup and shutdown procedures. Operating a concrete batch plant involves a series of procedures to ensure the production of high-quality concrete while maintaining safety and efficiency. Here are the general startup and shutdown procedures for a concrete batch plant. Startup procedures. 1. Check equipment readiness. Before starting the plant, ensure that all equipment, including mixers, conveyors, and weighing systems, is in good working condition. Check for any loose or damaged components. 2. Safety checks. Conduct a safety inspection to ensure that all safety mechanisms, emergency stop buttons, and guards are functional and in place. 3. Aggregate bins. 3a. Verify that aggregate bins are clean and free from any debris or contamination. 3b. Check that the gates and discharge mechanisms are working correctly. 4. Cement and admixture silos. 4a. Inspect cement and admixture silos for cleanliness and proper operation. 4b. Ensure that adequate stock levels are maintained. 5. Water supply. Confirm that the water supply system is operational and that the water is clean and free from contaminants. 6. Calibration. Verify that all weighing systems are calibrated correctly. This includes the calibration of scales for aggregates, cement, and water. 7. Batching sequence. Set up the desired batching sequence in the control system, specifying the type and proportions of materials to be used for the specific concrete mix. 8. Startup sequence. Start the plant following the manufacturer's recommended startup sequence, which typically involves powering up individual components systematically. 9. Batching and mixing. Once the plant is fully operational, initiate the batching and mixing process according to the preset sequence. This includes loading the aggregate bins, adding cement, water, and admixtures, and starting the mixer. 10. Monitor operation. Continuously monitor the plant's operation to ensure that all components are working as expected. Keep an eye on the mix consistency, water-cement ratio, and other relevant parameters. Shutdown procedures. 1. Finish current batch. Complete the current batch of concrete before initiating the shutdown process. 2. Clean out mixer and conveyors. After the final batch, ensure that the mixer, conveyors, and chutes are thoroughly cleaned to prevent contamination between batches. 3. Aggregate bins. Empty aggregate bins to prevent material buildup and segregation. 4. Cement and admixture silos. Close and secure silo access points to prevent contamination and moisture ingress. 5. Water system. Turn off the water supply and drain water lines to prevent freezing in cold weather or bacterial growth in warm weather. 6. Shutdown sequence. Follow the manufacturer's recommended shutdown sequence, which may involve powering down individual components systematically. 7. Safety measures. 7a. Ensure that all safety systems and emergency stop buttons are functioning correctly. 7b. Lock and tag out equipment as needed to prevent unauthorized operation. 8. Cleaning and maintenance. Conduct routine cleaning and maintenance tasks to keep the plant in good condition. Lubricate moving parts and address any wear and tear. 9. Record keeping. Maintain records of the day's operations, including batch quantities, mix designs, and any issues or deviations encountered. 10. Security. Secure the site, including gates and access points, to prevent unauthorized access. Proper startup and shutdown procedures are essential for the safe and efficient operation of a concrete batch plant. Adhering to these procedures helps ensure the production of consistent, high-quality concrete while minimizing downtime and maintenance requirements. C. Automation of concrete batching plant. Automation of a batching plant refers to the process of using technology and control systems to manage and optimize the production of concrete or other materials in a batch plant. Automation in batching plants offers several benefits, including increased accuracy, efficiency, and safety. Here are some key aspects and components involved in the automation of a batching plant. 1. Batching software and control system. The heart of automation in a batching plant is the software and control system. This system is responsible for controlling all the components of the plant, including the aggregates, cement, water, and admixtures, to ensure precise batching and mixing. Advanced PLC, Programmable Logic Controller, systems or SCADA, supervisory control and data acquisition, systems are often used for this purpose. 2. Sensors and measurement devices. Automation relies on various sensors and measurement devices to monitor the flow rates, levels, temperatures, and other parameters of the materials being used. For example, sensors can measure the weight of aggregates, the flow of water, and the temperature of the cement. 3. Material handling equipment. Conveyor belts, hoppers, and silos are often used to transport and store materials in a batching plant. Automation can control the movement of these materials to ensure they are delivered to the mixer in the correct proportions. 4. Mixer control. Automation systems control the mixer's operation, including the speed of mixing, the duration of mixing, and the addition of water or admixtures as needed to achieve the desired concrete mix consistency. 5. Data logging and reporting. Automation systems typically include data logging capabilities, which record information about each batch produced. This data can be used for quality control, reporting, and historical analysis. 6. Alarms and alerts. Automated systems can be configured to generate alarms or alerts in case of any deviations from the set parameters. This helps in quickly identifying and addressing issues to ensure product quality and safety. 7. Remote monitoring and control. Many modern batching plant automation systems allow for remote monitoring and control. This means that plant operators can monitor and adjust the plant's operation from a central control room or even remotely via a computer or mobile device. 8. Integration with enterprise systems. In larger operations, the automation system may be integrated with enterprise resource planning (ERP) software for better management of production schedules, inventory, and logistics. 9. Safety systems. Automation can also include safety features such as emergency stop buttons, safety interlocks, and alarms to protect plant personnel and equipment. 10. Energy efficiency. Automation can help optimize energy consumption by managing equipment operation more efficiently and reducing waste. 11. Maintenance monitoring. Automation systems can provide insights into equipment health and maintenance needs, helping to prevent unexpected downtime. 12. Quality control. Automation can significantly improve the consistency and quality of the final product by ensuring accurate batching and mixing. Overall, automation of a batching plant streamlines the production process, reduces human error, improves product quality, and enhances operational efficiency. It's a crucial component in modern construction and manufacturing industries. Friends, we have explained in brief about principles of concrete mixing and batching, concrete batch plant operation, startup and shutdown procedures, automation of concrete batching plant. We request all to mention your view and requirement in comments section of YouTube video. Also like and share to your friend. Also subscribe our YouTube channel Infomechanizer. This is 100% free.